AS Maths is right around the corner, and you're probably looking at a revision list at the moment that is about this high, which is why you're here now. You need someone just to cut through everything and tell you exactly what to revise for. Now, obviously, no one's got a crystal ball and can tell you exactly what's going to come up on the exam. However, most videos, they'll just list 10 topics and tell you to study those topics with no proof behind it. I went through every single exam report for 8MA01 from 2017 all the way to June 2024. And what I've noticed is there are 5 topics that are mentioned every single time and almost always have the same weighting when it comes to this specific exam paper. So if you're struggling with trying to work out where to focus your revision, by the end of this video, you'll have a concrete idea according to the data as to which topics you should be spending most of your time on when it comes to this final phase of revision. Just for a bit of context, when I was doing my A-levels way back, I actually never did this, and I kicked myself now for not doing it because it would have helped me so much more. It's literally like a cheat code. Okay, by analyzing the examiner reports, what you're able to do is to see exactly the classic mistakes that arise, so that when you are doing the paper yourself, even during the past papers, you know exactly what to look out for, and you know where most people trip up. And look, if most people are tripping up on something, chances are, just by probability, you are too, right? So by being able to see exactly where those issues are, you are literally one step ahead of everyone else. The reason I'm telling you this is because a lot of students simply treat revision like a checklist, right? They'll just go through every topic, weigh equally, tick the boxes and say, okay, I've got it. But in real life, it doesn't really work like that, because when you've got these past papers, inevitably there's some questions that take up more weight. So if you're spending most of your revision on topics that are only going to take up about 30% of the marks, you're really handicapping yourself. Okay, and it goes completely against the 80-20 rule, where basically 80% of the results come from 20% of the inputs, right? So it's a similar case here. So with that being said, what are these 5 topics? So the first one, and this should come as no surprise, is differentiation. Okay, now differentiation is extremely important because it occupies about 2 to 3 questions per paper. Sorry, on the paper. And what that means is 15 to 20 marks are automatically assigned to differentiation. Okay, so not knowing differentiation puts you at a massive disadvantage. But here's the problem: most people think they know differentiation, when in reality, they are slipping up on the questions that are supposed to get them the most marks out of that 15 to 20. So for instance, everyone knows how to find dy by dx. Everyone knows how to find the stationary point. However, what's tripping people up, as what the examiners noticed, is that a lot of people just don't know how to interpret the derivative for these harder type of questions. So specific examples of this are things like the second derivative test, where yes, you can find the second derivative, but can you actually evaluate whether the point is a minimum or maximum? Okay, using the second derivative. It's things like that that, again, I suppose on my end it sounds obvious, but for some students they just completely blank that for some reason, obviously according to the examiner. So that's something to really consider. It's not just about finding the derivative, it's about understanding and evaluating using the derivative. And similar to that point, when it comes to rates of change, okay, a lot of people, this is also flagged, they need to understand that when something's talking about a rate, okay, that is more often than not relating to time. Okay, so for those rates of change questions, you have to differentiate with respect to time when they're asking you to find the rate at which something is changing. Okay, because that was also something that's flagged. So in a nutshell, for differentiation questions, what was flagged here is it wasn't just about finding the derivative, setting it equal to 0, but it's about interpreting questions that use the derivative in the correct way. So for instance, you'll see something like find the rate of growth at t equals 4. Okay, and many students will just substitute t equals 4 into the original equation. But that's not the rate. What the rate means, okay, as I said this before, it means differentiate first and then substitute. Now this second topic carries close to the same, if not more marks than the previous topic. And that topic is exponentials and logs. And this occupies about 2 to 3 questions per paper. Okay, and most notably, the question you're most likely to get is that classic modeling question, and this pops up in nearly every single paper, if not every paper, for this exam series. You know the one. They give you a relationship like P is equal to A times B to the power of T, and a graph of log B plotted against T, which is a straight line. You read off the gradient, you read off the intercept, you find A and you find B. But there's an issue here, and this is the issue the examiners have called out. Where a lot of students are going wrong in these questions is in contextualizing the question. Okay, so for instance, something that was flagged was, for example, if a student is asked to interpret the value of B, the most logical mathematical answer would be, what's the gradient? But that's technically incorrect, because in the context of the question, what that really means is it's the multiplier, okay? So for instance, if we're talking about a painting, we'd say it's increasing by a factor of 1.18 per year. Okay, so specific, contextual, and relevant to that particular question. Okay, so the examiner reports literally call this out every single year. So when you're revising, make sure to really hone in on the interpretation section. Okay, because whilst it might look like a small amount of marks, that can add up, right? And those small amount of marks is the difference between something like an A and an A star. And another thing, if they say to show all stages of working, make sure to show all stages of working, okay? Because you know those questions where you're not supposed to use a calculator until maybe right at the very end, or not even at all. You need to show as much working as possible, okay? So don't be lazy and try to skip to the calculator, because that can easily lose you marks. What you need to do is develop your log manipulation skills, okay? And then you'll be fine. But the thing is, just don't be lazy, don't think you can get away with it, because they'll see through it. Now, number 3 is trigonometry. And almost all the time, from what I saw, it just boils down to 2 questions, virtually every time. The first one is a triangle problem, sine rule, cosine rule, etc. Now, the trap here is when you get 2 angles. So for instance, if you do inverse sine, maybe your calculator gives you an acute angle. But the obtuse one is sometimes the angle you actually need here. So if the diagram shows an obtuse angle anywhere, or the questions imply a side longer than expected, you need both. And this is something that the examiners flag. Now the second are the identity questions. Okay, now these ones are classics, where you're given some kind of identity and then you have to convert it into an equation that will allow you to solve. So this trap is twofold, okay? So students will miss solutions because they don't think about whether the variable inside the trig function has been transformed. So for instance, in the case of, say we have 3 theta, okay, here the range gets stretched, okay? So we're going to find the angles for 3 theta first and then divide. And the second point that pops up that the examiners mentioned is that students will sometimes write extra solutions just to be safe. That doesn't work. You need to know your range and be very meticulous when it comes to working out the specific angles that they want. Number 4 are questions about circles, okay? So this is coordinate geometry, and the question type barely differs from year to year. It always starts the same way. So you have to complete the square. That's how you find the center and radius. And then you're given some new information, a tangent line, a perpendicular gradient, a value of k. And you then have to find a coordinate, an equation, or more often, a range for values of k. Now, the range of k part is where a lot of students are going to lose marks, and that's because they only found one boundary, not both. So for instance, in 2023, students had to find values of k where the circle didn't touch the x-axis. So most students got the upper bound, but almost nobody got the lower bound because they didn't think about the circle existing in the first place. So k here had to satisfy 2 conditions, not 1. So when you see something like find the range of values of k, think to yourself, how many conditions does k have to satisfy here? That's very important. Now here's the last topic, and the good news is it's actually pretty easy if you know what to expect. Number 5 is the binomial expansion. And the interesting thing about this is that part A is usually super easy. Okay, all you have to do is expand. But part B is where the examiners are trying to trip you up. So that begs the question, what comes up in part B? Well, part B is basically using the result from part A to find an unknown. So that could be a value of A or maybe a coefficient comparison. So the fix here is simple. When you're practicing, don't just stop at the expansion. Force yourself to do part B, compare coefficients, find the unknown, and substitute back. And again, I know I've drilled down this point so many times, but it's so true. Just doing past papers, okay? That's just going to satisfy the volume for you to ensure that this shouldn't even be an issue. You should recognize these part B questions, right? If you're doing past papers, okay, at a large scale. And again, don't just do past papers, but refine it. So when you get a question wrong, go into that topic in more depth. And another thing that was flagged as well, so if you're squaring kx, the answer is k squared x squared, not kx squared. That was something that was flagged as well. Okay, 5 topics. Now before you close this video and say, okay, I'm done with this, make sure to watch this next bit, because this is going to be the differentiator that can be the difference between you getting an A and an A star. Every examiner report throughout this analysis I've done says the exact same 4 things. 1, and we've covered this briefly already, but show you're working. So calculator only solutions cost marks even when the number's right, and that's especially true on log questions. 2, when it comes to proofs and show that questions, students will often do the algebra perfectly but don't write the final sentence, okay? So always state your conclusion in proofs and show that questions, because otherwise that mark goes. 3, read the question for units, form, and rounding. Okay, so every modeling question asks for units. Every in the form question wants a specific structure. If you miss that, you lose the accuracy mark. And when you're explaining what something means in a model, be specific to the context of the question. Okay, so not just the gradient, you need the actual interpretation. So in the next week or so, that's where I'd focus a good amount of time and energy. Again, don't neglect everything else. If there are subjects that you're like completely in the dark about and you need to revise those, do that. But all I'm saying is these are the questions from my analysis at least that seem to have come up the most. Okay, so that should give you a good idea of what should most likely be coming up on the paper. But obviously don't neglect everything else. You need to study efficiently. And so if you're covered on everything else, and let's say you don't know these topics that well, then you need to drill these down for sure. One last thing. This system I walked you through, looking at the data, drilling exam style questions, and really focusing on what's likely to come up in the paper, that's the exact same system that I'm using at the moment on my platform to help students go from a C or a B to an A or an A star. It's targeted, evidence-based, and mapped to the actual exam instead of just a textbook. It's early days, so I've still got 3 free open spots at the moment. So if you want one, the link's in the description.